good afternoon. So my name is Andrew Mitchell. I'm from Natural Building Technologies, and I just want to dispel a number of myths today. The first one is, please don't assume that natural materials are some sort of niche and always will be some kind of niche product. What Gary said at the beginning is correct. It actually occupies currently a very small portion of insulation sold in the UK, but MBT saw an increase of sales about 50% last year. MBT are actually a distribution arm of Pavatex, who are a manufacturer of wood fibre, and Pavatex themselves are owned by Suprema, who are a very large company. They turn over about 3 billion. They occupy 90 countries. They have 59 manufacturing units, and they bought Pavatex for commercial reasons, not because they feel fuzzy and warm inside. So I just want to be quite clear about this. These are commercial mainstream solutions. These are not just a nice to have, despite the fuzzy picture of a tree just behind me. So we'll see how we get on. So first of all, health and well-being, that was what I was asked to ask about. You'll find there's a hell of a lot of overlap. It's like a vector diagram on steroids, I think these talks are going to be. So this was the Department for Health and Social Care in November last year, did a report worth a read, bit of bedtime reading. Page 9, you'll discover, it's a great title, by the way. Where's it gone? I can't go backwards. I would always support that. I don't see enough of it. But if you find page 9, you will see that they've basically saying that poor housing is contributing to about 1.4 billion to the NHS. So let's not be under any illusions that our built environment has a massive impact, okay, upon our standard of living, our health, and our well-being. Okay, so let's try and break this down a bit. So direct health issues. A lot of these we've touched on already. Off-gassing, okay? Let's try and understand there's a lot of stuff that is still unknown out there in terms of what our paints give off, what other manufactured products that we're bringing into our homes give off. There's a lot of talk about formaldehyde, etc., etc. We've heard a lot of this before. There's now enough opportunity to find, maybe not know all of the effect on the products that we're bringing into our environment have, but there's actually enough materials out there that we could choose that don't off-gas, okay? And a lot of the natural materials that are represented here today and part of the ASBP don't off-gas. Mold from moisture. We saw a bit of this graph, or the whole of this graph. I'm going to show it again because it's a good one. It's worth getting excited about. What you're looking at there is 0% relative humidity over on this side, your left, and 100% relative humidity on that side. Fungi, as you can see, generally starts to flourish and proliferate over 60% and higher. It's quite useful because it means we're not stuck with loads of trees that don't break down into component parts, and the same with all other biomass that's generally grown on the planet. Bit of an inconvenience if that was the case. We'd go around lighting loads of fires. Very unuseful at home, okay, because fungus generally, we don't want that stuff in our houses because it breaks down the materials that are around us and actually can have a serious effect on our health as well. There's actually a broader implication of this, which Mark's already shown, so I'm not going to go into the detail of that, but I would just point out one detail, which is the fact that at 50% relative humidity, where you're finding most of those species of virus and fungi and all the rest of it can't proliferate, is actually where you and I are most comfortable. You are most comfortable at around about 50% relative humidity. So if we improve the level of performance of our buildings, not just based on thermal but also on relative humidity, you'll have a far more comfortable, a far more healthy built environment. Bit of a problem with moisture. So this was a building, this is done by the BRE study. This was built in Wales. It was a timber frame buildings built in Wales in the 60s. Some bright sparks thought they should improve the thermal performance of the building. That sounds a great idea, okay? Unfortunately, they wrapped them up in a closed cell product, like a tea cozy from the outside, and within just 6 years, the buildings had rotted out. These buildings have now been razed to the ground. They no longer exist because they became literally unstable and unfit for human habitation. Irrespective of the health impact of a building falling on your head, there's other implications in terms of the mold and the breakdown and so on. I'm going to skip through these slides quite quickly, but I just want to show you the complexity of moisture within the built environment. This is when you're insulating a wall, a solid wall on the inside. Okay, we actually have 9 million solid walls still in the UK. A fabulous statistic is we have pretty much the most inefficient housing stock in the whole of Europe. But One way is to improve, obviously, by thermal performance, internal wall insulation. It's a good move, but beware, please. First of all, we've got vapor diffusion coming from the inside outside. If you want to know how that works, I'll talk to you later. But you're looking at moisture vapor entering the building fabric. You've now got a colder wall, so you could get interstitial condensation forming. Okay, the industry often treats that with a vapor barrier, which aren't very effective. So we really need solutions that allow moisture to get out more quickly than they got in. Okay, these are some of the benefits of natural materials, but I will, big health warning, another health warning, just using a material that is breathable is not the end of it. You need to understand the building physics. Okay, you need to make sure that the right material is used in the right place. Okay, so I'd encourage you to understand the building system rather than just an insulation material. Just to complicate matters further, it rains, as you're probably aware, and that creates liquid diffusion into the building fabric, and then the sun comes out and actually drives, some of that moisture gets evaporated off the wall, but it drives some of the moisture into the building fabric. You've insulated on the inside of your building, okay, you've reduced the heat load into that wall during the winter months, therefore you're increasing the moisture load in that wall during the summer months, okay? That needs to be understood as well. So it's complex, it is actually fairly easy to resolve, but it needs to be understood. So we get two, somebody said the other day, it's not rocket science, it's way more complicated, but it can be solved, and that's important. Next one we've already touched on as well, fire, bit of a health implication. You may or may not be aware of this, but fire toxicity is actually the biggest cause of death and injury, okay, in fires. There was an ASBP conference last week, which was excellent, I have to say, and fire came up as a big one. And it was important to note some of the research that was presented to us, that a lot of the standard insulation materials that we see being put in our building, as well as a lot of other materials, have a really high level of toxicity when they burn, okay? Gary mentioned earlier, natural materials are classed as combustible, but it's not just about the fact that it burns, it's how it burns, okay? What materials are being given off as it burns. A lot of cladding, as a sort of slightly thoughtful example, a lot of cladding is held onto a building with something called hands. They're like aluminium brackets in effect, okay? Aluminium melts at 600 degrees C, okay? Building fires are between 700 and 900 degrees C, okay? So you're talking about a non-combustible material that will fail catastrophically and quickly in a building fire. Just because it's non-combustible does not make it safe, and we need to actually understand this. PVC is pretty much non-combustible, okay? But in a fire, it's a chemical disaster, okay? And actually will kill people before smoke gets to them because of the off-gassing that's coming off it in the fire, all right? PVC has not been banned when the government banned combustible materials over 18 meters, okay? We did an 18-meter fire test, so we basically built a huge wall and set it on fire. Well, we didn't actually, the BRE did, in a controlled fire test using wood fibre insulation, and it passed the at-height fire test. We can't use that because it's now been banned, yet it would be argued that it is actually a safe solution for the built environment. Okay, acoustic performance. It's not just a bit of an inconvenience, actually noise pollution, it's not just annoying, okay, it's actually bad for your health. So there's a bit of a survey done by Mr. Thomas Monzel. Quite interesting stats. So 10 decibel increase because it was near aircraft noise resulted in 28% increase in anxiety for the people who were living nearby, okay? I think as human beings, we're incredibly resourceful and incredibly our ability to adapt and tolerate stuff is quite an asset and a gift, but I think the problem with that, the downside is we put up with an awful lot of crap, frankly, and noise levels is something that really needs to be addressed. One of the benefits that's already been highlighted today about these natural materials is the fact that it performs incredibly well acoustically. Says itself. Okay, indirect health issues, just thought I'd touch on this. Pollution, plastics, another big gig at the ASBP conference. We had Emily Penn, recommend you to look her up. These are a couple of her slides. Those 5 lumps in the oceans are basically large gatherings of plastics which are effective because of the currents that we have in our oceans and our seas. She does these expeditions on boats, all-women crews, to go and find these masses of plastic, only to discover that they don't exist. on the surface, but they do exist under the surface at a scary volume, okay? So they catch fish, they find loads of plastic in the gut of the fish, they do x-rays of plankton, only to actually discover that 2 of those bits are actually plastic, okay? And it's because the plastic gets broken down into lots of little pieces, but still remains as part of the ocean, and it's very good at attracting a load of nasty stuff. 12.2 tons plastic, million tons, I should add, go into our oceans every year. Okay, plastic is a brilliant material. I grew up with a background in design, loved the stuff, extremely useful, extremely effective material, solves a lot of problems. But the way in which we use has to change. Okay, and the way we use it in our built environment has to change. We need to look at ways of limiting that, which is why we're here today. Okay, indirect plastic and CO2. It's a bit of a kind of elephant in the room. If you want an extra elephant in the room, I'm going to final plug for the ASBP. At the end of the conference, Gary, who closed the meeting, actually drew our attention to this young lady. So it's a TED talk. I'd encourage you to go and listen to it. It's about 10 minutes of your time. If a 16-year-old can explain so clearly why we've got to get our act together, I kind of feel like we've run out of excuses. Okay, so I would seriously encourage you to listen to that. And then the reality, what she says is basically, we've got the solutions, we just need to use them. Quick stat for you, about 1.2 tons of carbon gets locked up for every ton of product of wood fibre. I'm not trying to just plug wood fibre. This is a lot of the case with a lot of natural materials. It's just that's the only one I really know about, okay, because that's my day-to-day. Okay, that's after it's been shipped over. Currently, we have to make it in France and in Switzerland. Okay, that includes the transport shifting. Okay, if we were to make it in the UK, then we'd reduce that even, or we'd increase the CO2 lockup even further. Well-being, I'll just sort of wind up now. Again, funnily enough, acoustics, we've done that already. Summertime overheating, which Chris did a great job earlier. Just a quick sort of recap, 3 ways you generally find your building overheats. Too many people, too many appliances, so it's an internal thing. Solar glazing, so fenestration basically, so south is a bit of a, you can sort that out with a bit of fenestration, but east-west is tricky. But the final one is frankly just heat directly going through the building fabric. Okay, lightweight structures, timber, steel, concrete even, because they have big spaces between them, are generally far more susceptible to overheating. Okay, and they're going to be far more the building pattern of the future, because in terms of modern methods of construction, the fact that we need to build houses more effectively, more off-site construction, etc. So we need to understand better how they're operating. Okay, the amount of energy that the sun throws down on your building in the summer is like ridiculously greater than the little boiler that is in your house that's keeping you warm in the winter. That's the reason why the insulation in the roof doesn't keep the heat out. Okay, it changes. It's not about convection, which is generally how insulation works, trapping air. It's actually about soaking up the heat and conduction. So that's a little graph, but basically the black line is the external amplitude. The blue line is if you fill the roof up with mineral wool. Okay, so that's the decrement delay is those 2 peaks that Chris talked about earlier. Okay, and then you can see a much more stable line by using a high mass material, in this case wood fibre. To give you another example, basically if you were using about 160 mils worth of wood fibre, that's how much PIR you'd need, and that's how much mineral wool you'd need to create the same level of decrement delay and keep your building cool in the summer as well as the performance in the winter. So I hope you've got the basic message, which is actually insulation does a lot of things, and it's worth thinking about all those things because they have a huge impact on the title I've been given, our health and our well-being, as well as actually just the performance of our buildings and the environment around us. So thanks very much for your time, and I'll step down. Thank you.